Moving on, we're going into section 2.3, linear functions and slope. So we're going to be mostly doing review of what is a slope, point slope form, slope-intercept form, and then, a little bit about using linear equations for some application. So start with slope. So when we talk about slope, we have a pair of points that we call x sub 1, y sub 1, and x sub 2, y sub 2. So the slope of the line through the distinct points x1, y1, and x2, y2 is going to be the change in your y values between 1 and 2 over the change in your x values between points, the 1 points and the 2 points. Or in other words, we call this the rise. So the change in the y is the rise, and then the change in the x we call the run. So to make sure that we maintain the correct sign on our slope, we do have a formula to help us with that, which is going to be y2 minus y1, x2 minus x1. So you notice the 2's sit on top of each other and the 1's sit on top of each other. Like I said, that's just to make sure we get the correct sign on the slope. And we only get a slope, or a value for it anyway, just as long as that the difference between x2 and x1 is not 0. So we want to find the slope of a line that passes through the points 4, -2, and -1, 5. So it doesn't matter which ones are your 1's or which ones are your 2's. I just usually go in order. So these ones came first, so I'll make these x1, y1. And these came second, so I'll make them x2, y2. Now slope, if you remember, is going to be y2 minus y1 over x2 minus x1. So my y2 was this 5. My y1 is the -2. So we're subtracting a -2. So be careful when you are subtracting negatives or you're adding two negatives. Then we have our x2, which our x2 is the -1. Subtract our x1, and our x1 is 4. So we're going to get 5 plus 2 on top is what that turns into. And this is just going to be a -5. So this is positive 7 over -5. Or if you want to, you just stick the negative out front. So just as a note, it doesn't matter where that negative is as long as there's 1. All these fractions are the same. So 7 over -5 is the same as -7 over 5, which is the same as -7 over 5. So this would be my slope. Now, just to point this out, had I gone the other way and I said this was x2, y2, and this was x1, y1, it's not going to make a difference. So you should be able to find slope using the points in either order. So if I do it this way, then my y2, my y2 is -2. My, little typo there. My y1 is going to be the 5, so -2 minus 5 now. And then we're going to have on the bottom, x2 is the -1 minus the x1, which is now the 4. Oh, I'm looking at the wrong points. I'm sorry. The blue ones. My x2 is the 4 minus my new x1, which is the -1. So in that case, we get -7 over 5, which is the same as -7 over 5. So it doesn't matter, just as long as you keep the 1's on top of each other and the 2's on top of each other, you're going to be good. So take a moment. You have a couple of these. One of these is going to be a little weird, but you have 3 sets of points here, and just find the slope between the 2 points. And if you need to, simplify the fraction if you can. Okay, so I got our formula here towards the top. So we'll do like we did before. We got 0, 4. We'll make that x1, y1 because it came first. And then we have 8, 6. We'll make that x2, y2. Just make sure the x's or your ones are on the same set of points, and your twos are on the same set of points. Now my slope will be y2, which is 6, minus y1, which is 4, divided by x2, which is 8, minus x1, which is 0. So here we're going to have 2 on top and 8 on the bottom because we're just subtracting by 0. Or if we reduce that, that's just 1/4. Okay. Now for the next pair, let's do this different. We'll make this the 2's, x2, y2. Like I said, it's not going to make a difference. We'll make this one x1, y1. So we'll have y2 is going to be -3 minus y1, which is -7. Then we're going to have x2, which is -3, minus x1, which is just 1. So we have a -3 minus a -4, so -3 plus 4. Sorry, -3 plus 7, which is going to be 4. I've gotten ahead of myself. And then we'll have -4 on the bottom. So we should end up with a -1 for my slope. All right, and then for my last one, let's just go back to x1, y1, x2, y2. Then we're going to have y2 is -6 minus y1, which is 6. And then we're going to have x2, which is -2 minus x1, which is 4. So in here we get 0 over -6, which is 0. So sometimes you can end up with a slope of 0. So slope-intercept form of an equation is going to be this form, or sorry, slope-intercept form of the equation of a line is this equation right here. So this is the one most you've seen, y equals mx plus b. M represents our slope, which also later on when we talk about application problems that's going to represent the change in your y over the change in your x. So it is a rate of change. So slope is a rate of change. And remember, it's always going to be the change in your y values over the change in your x values. Your y-intercept, we call b. So y-intercept is when x is 0. So this represents where the graph of the line crosses the x-axis or when x is 0. So sometimes we consider this to be like an initial value when we're talking about application problems, because initial value is when your x is going to be 0. We also have point slope form for the equation of a line. So there's pluses and minuses to slope-intercept form and point slope form, which we're going to get into. But when you have point slope form, you just need a slope and you just need a point that the line is going to pass through. So we have our slope m and we're going to pass to the point x1, y1. So what this really comes from is that slope formula. So you have that slope formula and you had your your x2, y2. We just want to make those not, in this case, they're constants because there's going to be a value attached to them. We know we want to make them variables. So we've made them variables. We would get y minus y1 over x minus x1. So if we multiply both sides by your x minus x1, we'd end up with, sorry, m, need my m first, m, x minus x1 equals y minus y1. So you see, same formula here, just switched. So it comes from that slope formula. It's just that one of our sets of points are going to be variables and another set are going to be a constant. We know what those points are going to be. All right, so we got y minus y1 is equal to m times x minus x1. And as I said, we'll put this here, that x and y are the variables. M, x1, and y1 are constants. We are going to know a value for them. All right, so like I said, just remember x and y without any subscript, those are variables. Because that's where this one gets people confused, is they keep trying to find something to stick in for those points. So we want to write an equation in slope point form for the line with a slope of 6 that passes through the point to -5. Then we want to solve the equation for y so we can write it in slope-intercept form. There was a typo there. So what we like is that the point slope form is very, very nice to help me write equations. And my slope-intercept form is very, very nice for me to understand the equation. So there's pluses and minuses to both of them. So we know that m, my slope, is 6. We have a pair of points, 2, -5. So we know our points x1, y1 are going to be 2, -5. We have an equation which says y minus y1 is equal to m times x minus x1. So this is our point slope equation. That's the right form. I'll try to remember if your book said form or equation, because another one it says equation. So we have y. We know that y1 is going to be -5. We know m, my slope, is 6. And then we have x minus x1, and we know x1 is 2. So this is my point slope form. We could simplify it a little bit if you wanted to and make it y plus 5 equals 6 times x minus 2. That still stays point slope form. So that finishes the first part. We got our equation in point slope form. Now we want to solve for y. So what we're going to do is we're going to distribute the 6 through first. So we get 6x minus 6 times 2, which is going to be -12. Then to get y by itself, we'll subtract that 5. And we get that y is equal to 6x minus 17. And this is going to be my slope-intercept form. So like I said, point slope form is really nice because as long as I have a point and a slope, I can stick them in there and I get an equation. And then all I have to do is solve for y to get my slope-intercept form. And slope-intercept form, we can easily see from it, my slope is 6 and my y-intercept is -17. It also is going to make that one easier to graph for us. All right, so we're going to do this again, but now we just have 2 points. So we're going to write an equation in point slope form for a line that passes through the points 3, -5 and 7, 1, and then solve the equation for y. And we're going to write it in, once again, slope-intercept form. All right, once again, so there's a problem here because remember, this is slope-intercept form. So I have a point, I have 2 sets of points, but I don't have an m. So in this case, I have to find slope first. So let's say these points are going to be my x1, my y1, and these points are going to be my x2 and y2. Like I said, it doesn't matter which ones I pick. And my slope is going to be, so remember, y2, so it's going to be the 1. Or another way you can think about it is like I have to put the 1 here, so then the 7 has to go underneath it. And then this is my y1, so -5. And then the x has to go underneath it. So I'm going to end up with 6/4. So I get a slope of 3/2. Just double checking it. Yep, that'd be it. So now I can use my slope point form. So I got y minus y1 equals mx minus x1. All right, so like I said, I could pick this pair of points or this pair of points. I just happen to label these ones my x1, y1, so I'll just use them. So I'm going to have y minus my y1, which is going to be -5, again. And then my slope, we said, is 3/2. And then we're going to have x minus my x1, which is going to be the 3. This one's not going to be pretty for us. So we're going to change that to y plus 5, 3/2, x minus 3. So we have our slope point form. Point slope form. I always say that backwards. It's a slope intercept form. Then we're going to solve for y. So we have y plus 5 equals 3/2 x minus 3. So we're going to put fractions here. So we're going to end up with y plus 5. If I distribute this, I end up with 3/2 x. And then 3/2 times 3 is going to be minus 9/2. So the next thing I want to do is I want to subtract 5 from both sides. So I'm going to have y is equal to 3/2 x minus 9/2 minus that 5. So just to help us with this, so 5 I can rewrite as 10/2. So what I really have here is that y is going to be equal to 3/2 x minus 19/2. Okay. So take a moment if you're writing this, you might want to pause because I'm going to go back and show you what would happen if I use the other set of points. Okay, so when we use x1, y1, we said it was going to be 3, -5. This was our point slope form, our slope intercept form. So now I'm going to say my x1, y1 is going to be the 7, 1. So now we're going to have y minus y1, which is going to be 1. And then my slope is still 3/2. That hasn't changed. And then we're going to have x minus my x1, which is the 7. So this is going to be my point slope form. So we do get a different point slope form. And then if I solve for y, so we have y minus 1 equals 3/2 x minus, and if I multiply that over here, so 3/2 times 7 is going to be -21/2. We're going to have y equals 3/2 x minus 21/2. So we have to add the 1 to both sides, so plus 1. Y equals 3/2 x minus 21/2 plus 2/2. And we get y equals 3/2 x minus 19/2. So we get back the same slope intercept form. Just a second, I'll move something here. Intercept. So make a point here. So this equation, and then we got the same point slope from all of them. All of these are all equivalent equations. So for that line, they're all equivalent. So what it means to be equivalent equations is that they all have the same solution sets. Or you can think of it as if you graph them all, you would all get the same graph back. So they are all equivalent to each other. It's just different forms of saying the same line. All right, so we're going to find the equation of a line in point slope form given the following. And then afterwards, I didn't put it on here, but I'd still say solve for y in the end to get slope-intercept form, just so you get that practice in. But you're going to start with point slope form and just get the line. So you first one, you have a slope and a point, and the second one, you have 2 points. All right, so like I said, we're going to rewrite in slope-intercept form when we're done. We're going to start with A here. So we know point slope form is y minus y1 equals m times x minus x1. So we have an m, we have an x1, and we have a y1. So we're going to have y minus -7 is equal to 1/2 x minus 8. So we have y plus 7 equals 1/2 x minus 8. So that fits our first criteria. We got point slope. Now we just need to rewrite it into slope-intercept form. So that means solve for y. So we're going to have y plus 7 is equal to, so I've dropped my parentheses here, 1/2 of x and 1/2 of x times 8. That's going to leave us with -4. So we subtract 7 from both sides. We get y is equal to 1/2 of x minus 11. Now we got slope-intercept. So B, first thing we need to do is we actually need to find slope. So let's call this x1, y1, x2, y2. So my slope will be -14 minus 7, x2 minus x1, or sorry, y2 minus y1. And then we'll have 4 minus -3, or x2 minus x1. So we get -21 over a +7. So this is just -3. Now, like I said, we made these the ones, it's not like it's going to matter. So now we have y minus y1, which is 7, equals my slope, which is -3, times x minus x1, which is -3. So now this is y minus 7 equals -3 times x plus 3. There's my point slope. Save myself some room. We're going to start working up here. So if I start solving for y minus 7 equals -3 times x, and -3 times 3 is going to be -9. We add 7 to both sides, and we get that y is going to be equal to -3x minus 2. And you can always check these by taking one of your points and plugging them back in. Like if I take this one and I plug back in that 4, I have -12 minus 2, which is going to give me back my -14. So it's a way to double check your points. So I always suggest using the second pair of points as a way to check. And so going on to graphing, y equals mx plus b is the easiest form to use to do most graphing. So it can be a little dependent on what you're dealing with. But we're going to start with this. Let's start with the y-intercept form. So all we need to do is just plot that y-intercept on the x-axis, and then we just figure out the slope from there. So we obtain the second point by using the slope. We write m as a fraction as the rise over run, and we start at a point containing the y-intercept to plot the second point. So once we have 2 points, that's all we need to make a graph. So here we have my function fx equals 3/5 x plus 1. So we'll start with the easy part. Let's graph that y-intercept. So this represents a y-intercept, or a point that is at x equals 0, y equals 1. So it'll be this point right here. Now the slope. Remember that slope is the same as your rise over your run. So I always say keep the run the positive one. If you have a negative slope, then the rise would be the negative part of it. But this one was just all positive. So this tells me this is a change in, well, let's write change. Go. This is a change. If you didn't know it, this sign means change. A change in your y values over a change in your x values. So my x values change by 5. So we go 1, 2, 3, 4, 5. So there is my run. And then my rise is 3. So I rise, or my y changes by 1, 2, 3. And that is going to give me my second point here. So we have our point here at 0, 1, and then we end up with a new point that is going to be at 5, 4. And from here, all we have to do is we just have to draw a line connecting the 2 points. I'm trying to pick a good spot so I don't mess this up with this arrow. There we go. And there we go. We have the equation for our line. Or not the equation, I'm sorry. We have the graph of the equation of our line. So you have a negative slope. So like I said, try to keep the run positive and make the rise either a rise going up or it's going to go down. So put the negative on that part. That will make it easier to do. But just try number 3 here, and then we'll come back and we'll finish it. So we see our y-intercept is at 2. So it's a 0.02, 1, 2. Then our slope, I had the negative out front, so the negative 4/3. So I have -4 over 3. So I just stuck the negative to the top because this is my rise and this is my run. So it keeps my run positive. So I run 1, 2, 3. And then instead of rising, I'm going to fall 1, 2, 3, 4. I said 1, 2, 3, 1, 2, 3, 4, just so I get this placed. Just draw another line through it so I can see that. So it should go all the way across, but it's fine. And that should be the equation for that one. So notice the first one, we had a positive slope. So it was a increasing function. It increased all over. Here we have a negative slope, making it a completely decreasing function. It decreases across the entire domain. Now try number 4. So number 4, think about how can I rewrite that slope as a fraction to help you graph that slope. So here we see the slope is going to be -3. So y is at 1, 2, 3, -3. right, that's my y-intercept. My slope is 4, so we can rewrite that as 4 over 1. So my rise is 4, but my run is 1. So in this case, we just go over 1, up 1, 2, 3, 4. 1, 2, 3, 4. It's about there. It's a little off. There you go. So just graph the line through it. So that would be the graph of 4x minus 3. All right, so we saw this earlier. So we had a slope that we found that that was just 0. So when we have a slope that is 0, that is going to represent a horizontal line. So a horizontal line is given by the equation of the form y equals b, where b is the y-intercept of the line. The slope of the horizontal line is going to be 0, which is why we don't have an m. I'm trying to get my writing tool back. That's why we do not have an m, because this is just saying we got y equals 0. Y equals a 0x plus b. So just an example to see why this is going to look the way it does. So y equals 3 is in the rectangle. We're going to graph it in the rectangular coordinate system, and we want to know what is the slope. So if y is 3, if x is 2, what's my only option for y? Well, y would have to be 3. If, say, x is -5, what option do I have for y? I only have one choice for y, which is y will have to be 3. Let's say x is 6 then. What choice do I have for y? Well, I only have one choice, which is 3. So no matter what x is, y has to stay 3. 2, 3, 4, 5, 6. So what we see here is that only thing we can get is a horizontal line. And we saw this once before, but I'll do it again. If I was to try to find the slope, let's say this is going to be x1, y1, and we'll make this one x2, y2. That slope is going to be 3 minus 3 over -5 minus 2, which is going to give me 0 over -7, which is just 0. So horizontal lines can be functions. We can have a vertical line. A vertical line will not be a function, however. So this was a little different to think about. So a vertical line is given by the equation of the form x equals a, where a is just going to be the x-intercept of the line. So we haven't worried about x-intercepts before. So the slope of a vertical line is going to be undefined. So we'll see here in a minute why that's going to happen. So if I have x is equal to 3, if I pick y values this time, let's say y is -4. If y is -4, my only choice I have for x is 3. So 1, 2, 3, 1, 2, 3, 4. If y is 0, my only choice for x is that x has to be 3. If, say, y is 10, y is 10, my only choice I still have for x is x has to be 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we see what we're going to get is that we're just for every y value, x has to be 3. So we get a vertical line like this. Now, once again, let's say these points are going to be my x1, y1, and these are going to be my x2, y2. And we find slope. Well, slope will just be 10 minus -4. And then on the bottom, we'll have 3 minus 3. So we're going to have 14 divided by 0. And we know anything divided by 0 is just going to be undefined. So that's how we always end up with an undefined slope, because all my y values are the same, meaning when I do my slope formula, I always end up dividing by 0. So on the same set of axes, just want you to graph the lines y equals -2 and the line x equals 7 on the same set of axes. So remember that when y equals -2, the y-intercept's -2. When x equals 7, that means the x-intercept is 7. I'll give you a way to kind of help you graph that. All right, so I just put a few points in there to kind of help you out if you need to think about it. But really all it is that y equals -2. It's y equals -2 right here. That's what I'm looking at. So it doesn't matter what my x value is, because if it's -5, y is still -2. If x is 6, y is still -2. So we're just going to get a vertical line that intersects at y equals -2. If x equals 7, then what we see here is that x is going to be 1, 2, 3, 4, 5, 7. That's where x equals 7. That's my x-intercept, and it doesn't matter what x is. Or sorry, it doesn't matter what y is. X always stays 7. So we could be here at 7, 4, because if y is 4, x still has to be 7. If y is -3, x still has to be 7. So we get a vertical line here. And just a note, this one, slope is undefined. So just want to point out that an undefined slope doesn't mean it doesn't exist. It means that I just don't know how to express it. And a slope of 0 also doesn't mean the slope doesn't exist. It just means that the slope is just has a value of 0. It doesn't increase or decrease. Basically, we have a constant function. All right, so as I said, there were multiple ways to write a linear expression. So another one we have that helps us with graphing. So y equals mx plus b is another, it's really nice for graphing. Point slope can be kind of useful for graphing, not necessarily the greatest, but it can be helpful. We also have general form of the equation of a line. So the general form for a linear equation is ax plus by plus c equals 0. So we have usually anytime we have any kind of equation and it's set equal to 0, that's some sort of like general form. So a, b, and c are going to be all real numbers, and a and b cannot both be 0. One of them has to be anything other than 0, or otherwise we just have a constant equal to 0. So that means you can have something of the form 3x minus 5y plus 15 equals 0. That's a linear equation. But I can also have 3x equals 12. That's still going to work here under my general form, because the a is not 0, even if b is. Oops, sorry. Plus 12 equals 0. I can have the y component there and the x component gone. So I can have 4y minus 18 equals 0. So any of these forms is going to be the general form for a linear equation. So that's what it means that a and b both cannot be 0. Just one of them has to be something other than 0. We have to either keep the x or we have to keep the y variable. So we want to find the slope and y-intercept of a line whose equation is 3x plus 6y minus 12 equals 0. So anytime you need to find slope and y-intercept, that means we're just going to solve the equation for y. Just a second, I'm gonna have to restart this. So solve the equation for y, we have 3x plus 6y minus 12 equals 0. So we can do this step by step. So let's move the 3x. So if I subtract 3x from both sides, I'll have 6y minus 12 equals minus 3x. Then I could add the 12 to both sides. And I'm going to get 6y is going to equal to negative 3x plus 12 because I can't, these are not like terms, I can't combine them. Then the last thing I need to do is just divide by 6. So we're going to have y equals, so we have a summation over a fraction, or summation in the numerator. We can break that up over the denominator, and we can have negative 3x over 6 plus 12 over 6 means y is going to be negative 1/2 x plus 2. So now we see that slope is negative 1/2, and y-intercept is going to be 0, 2, or you could just say it's y equals 2. So you have all the information now. So for number 6, you're going to graph, I think I got my words out of order. You're going to take this line and you want to graph it and find the slope and the y-intercept. So you probably want to find the slope and y-intercept first, then graph it. So like I said, it would be easier if I had slope and y-intercept first. So if I solve for y, I have 6x minus 4y plus 12 equals 0. So if you wanted to and make it easier, you could just move the 4y. So I can add 4y to both sides. So I have 6x plus 12 equals 4y. Then to get the y by itself, divide everything by 4. So I'll have 6 over 4x plus 12 over 4 equals y, or you could say y equals 3/2 x plus 3. So now we know that y-intercept is 3. We know that slope is 3/2. So we move over 2 because we run 2 and then we rise 3. Trying to eyeball this just right, and I'm keep missing. There we go. And that would be our graph. So you just want to make sure if your graph is right, just as a way to kind of check it. So this point here is at 2, 1, 2, 3, 4, 5, 6, 2, 6. So we'll just see if 2, 6 works in here. I'm just doing a check. So 6 times 2 minus 4 times 6 plus 12. Is it going to be equal to 0? We're going to get 12 minus 24 plus 12, which is going to be 0 equals 0. So it checks out. We did graph it correctly. Okay, so going back to x and y-intercepts. So an x-intercept is a point where the graph of a line or curve intersects the x-axis, as we see here. Oops. Get my stuff again. And we see that when I have my x-intercept, this happens when my y value is 0. My y-intercept is a point where the graph or the line of the curve intersects the y-axis. And we see this happens when your x values are 0. So we intersect the x-axis when y is equal to 0, and we intersect the y-axis when x is equal to 0. So we can use this knowledge to help us find x and y intercepts without graphing. So we want to use intercepts of a graph 8x plus by plus c equals 0. So another way to graph this without having to, it's another way that will help us so we don't always have to find x and y intercept. We could just find x-intercept and y-intercept. So we can find x-intercept by letting x be 0 and solving for x, and that will be 1 point for our equation. We can find the y-intercept by letting x be 0 and solve for y, and that will be another point for our equation. Then we just graph those 2 points, we can just draw a line straight through it. So just as long as a, b, and c is not 0, the graph of ax plus by plus c equals 0 will have a distinct x-intercept and y-intercept. So this only works if a doesn't equal 0, nor b equals 0. So we want to find our x and y intercepts to graph. So x-intercept, this is when y equals 0. Y-intercept, this happens when x is equal to 0. So if I want to find my x-intercept, I'm going to take my 3x plus 2y minus 6 equals 0, and I'm just going to replace the y with 0. This is going to leave me with just 3x minus 6 equals 0. All right, because 2 times 0 is just going to be 0. So if I just solve for x, add 6 to both sides, I'm going to have 3x is equal to 6, divide both sides by 3. We get that x is going to be equal to 2. So I have an x-intercept at 2, 0. I'll graph it right there. Now for the y-intercept, that happens when x is equal to 0. So now I'll just replace x with 0. So I'll have 3 times 0 minus 2y minus 6 equals 0. So it's going to leave me with 2y minus 6 equals 0. If I add 6 to both sides, I have minus 2y equals 0. If I divide both sides by negative 2, I'm going to end up with y is going to be equal to negative 3. So I'll finish this right down here. So that means I have my y-intercept is going to be the point 0, negative 3. Usually the biggest mistake I see here is kind of like switching your points. You get your x and your y-intercepts confused, and then this you might end up, when you do this, say it's a y-intercept, and you do this, and you tell me it's an x-intercept. Like I said, that's the biggest mistake I see. So just be careful that y-intercepts happen when x is 0, and x-intercepts happen when y is equal to 0. So on number 7, take a moment and you have 6x minus 4y plus 12 equals 0. So we already graphed this once. We're going to look at this again, but this time you're going to graph using your intercepts. So find the x and y intercepts and then graph again. Okay, so x-intercept, that means we're going to replace y with 0. So we get 6x plus 12 equals 0. So when we move our 12 to the other side, we have 6x is equal to negative 12. If I divide by 6, then we see that x is going to be equal to negative 2. So negative 2, 0 is going to be my x-intercept. Now y-intercept, I'm going to replace x with 0, so I'm going to have 6 times 0 minus 4 times y plus 12 equals 0. That's going to leave me with negative 4y plus 12 equals 0. So once again, if I subtract 12 from both sides, I end up with negative 4y equals negative 12. And if I divide both sides by negative 4, we're going to get y is going to be equal to negative 4. Y is going to be equal to 3, giving us a point at 0, 3. So we have x is negative 2, and then we have y is going to be here at 3. And as we see, last time we said we had a slope of 2/3, so you're seeing that slope of 2/3 here. So we still get that same line back. So application, use the data points 317 and 57.04 and the points 354 and 57.64 to obtain a linear function that models the average global temperature, so f of x, for the atmospheric carbon dioxide concentration of x in parts per million. Just so we understand what's going on here, we're told that we are looking for a linear function f of average global temperature. And the x value is the carbon concentration. So we are looking for a function that is going to be, sorry, a function of carbon dioxide concentration. So we want to round m to 3 decimal places and b to 1 decimal place when we find this. So we have a set of points. We have an x and an f of x, or x1, f of x1, x2, f of x2. And we know we can replace that with y1, y2. Just remember that when we finish this, y has to be f of x. So my slope here is going to be, my y2 is going to be 57.64. My y1 is going to be 57.04. And then my x2 is 354 minus my x1, which is 317. So on top, we're going to have 0.6 is going to be left over. Second, let me get my bottom. 357 plus 3. And then we're going to have 37 on the bottom. So this would have put in your calculator, but 0.6 divided by 37. 0.6. It is going to be 0.0. So how many decimal places? 0.36. Yeah, so we have 3 decimals, 0.016 is what we should have. So that's average global temperature per increase in carbon dioxide. We'll say it like that for right now. Okay. So from here to finish this, we'll do the other part along the side here, or I think we fit it at the bottom. So I'm gonna change color. So we have a slope, so we have an M, and we have an X1, Y1. So now we just take Y minus Y1, which is going to be my 57.04, is equal to my slope, which is 0.016, times my X minus my X1, which is 317. So Y is equal to, or sorry, let's go back a step. Y minus 57.04 is equal to 0.016x minus, let me do this part again in my calculator. So 0.016 times 317, 5.072. So then we just have to add the 57.04 to both sides. And we're going to get that Y is equal to 0.016x minus, oh, it will be plus this time, plus 51, and I'm rounding to one decimal place, so 51 point, well, it'd be just 52 then. 52.0 if we're going to round it. I get 51.96, so I'll just round up to 52. All right. So we just want to check this. Just check with the other point. So what is Y going to be? And we're just going to get close. If X is 354. So we get 0.016 times 354. Little typo here. This should be a plus. That should be positive. Plus 52. We get something that's close. We're going to get Y is going to be 57.664, which is really, really close to what we got here. And because we had some rounding and some estimates, that's good enough. So this would be my equation. So this would be my function. F of X is equal to 0.016x plus 52.0. Because we wanted to have a function. All right, so I'm going to ask a little extra here, but in 2000, the population of San Antonio, Texas was estimated to be 1,156,000 people. I did do some rounding here. And the population was 1,490,000 as of January of 2024. Based on this information, make a linear model of the population growth for years after 2024. So that is going to tell you where your initial growth is going to be, what we think it is. Okay. So this time I don't give you ordered pairs. You have to figure those out. So we want to make a linear equation that models population growth after so many years. So the model is supposed to be population growth. So I'm going to say f of t is going to be population. And then we're going to use t as our variable instead of x. And that's going to be years. And that's going to be years after 2024. So that means we have ordered pairs where we're going to looking for t. Remember, this is going to be simply by y. So my ordered pairs are going to be, I have the year 2000 and the population was 1,156,000. So that's one set of points. So T1, and we'll say Y1. And the other ones will be our twos. So we'll do 2024, and in 2024, the population was 1,049,000. Let me get rid of my extra commas. We've got too many commas going on here. And we're going to call this T2, and we'll call this Y2. All right, so first thing we need to do is we need to find slope. So what we would have for x's is now my t's. So we still do this. It's just going to be y2 minus y1 over t2 minus t1. So we have a population of 1,049,000. 1,490,000 minus a population of 1,156,000. And then we are going, T2 is 2024, and then T1 is 2,000. Okay, so let me get the first one. 1, 2, 3. 1, 2, 3. Sorry, it's counting my zeros. That is a difference of 334,000 people divided by a difference of 24 years. So let's say we'll just round this by, let's say we'll do like the last one, 3 decimal places. So this is going to be 13,916.667. And this is how many people we're getting per year. Okay. So if you got a little stuck in this part, that's fine. So based on this information, we will make a linear model of population growth after the year 2024. So we want 2024 to be the initial year of the model. Or otherwise, we're going to think of it as being year 0. So that means that this we can rewrite as a 0. So we actually are starting off at 0, and my population, I had a missing 0 up here, I believe. Yeah, 4 zeros. So what we're saying is that we want to start with my initial population to be the one that is 1,490,000. So in this case, we have a B. So we have an M and we have a B. So we have Y is equal to 13,916.667 T plus 1,490,000. So we can say that my function f of t is this right here. So the last part is we want to estimate what is going to be the population size in 2030. So 2030, this is just 6 years later. So that means we're looking at t is going to be equal to 6. So if we figure out what f of 6 is, they'll tell me the year, the population in that year, or our guess for it. So let me see, 13,916.667 times 6 plus 1,490,000. That should give us a population of 1,573,500 approximately. So this is what our guess of the population is going to be in 2030.